Hello everyone. In this video, we'll be looking at the question letter combinations of a phone number. And I find this question particularly interesting because of the practical implementation of it, which we see almost on a daily basis. Why do I say that? It is because of this picture right here. If you notice this, you'll find it very similar to the keypad on the mobile phones that existed before the smartphone era. Of course, we still see some of those floating around every now and then, but they were quite dominant at that time. That was the technology, right? And every time we had to type out a message, we had to click one button multiple times to get the right letter. For example, if I wanted the letter B on my message, I had to type the number two times to get to the letter B, right? And we can even do this on the smartphones of today, and you will see that in this keypad over here, we still have this exact same mapping that you see on your screen. So go to your smartphone, go to the contacts page, and just type some numbers out based on this mapping, and you will see that the relevant letters are popping up and showing the relevant contact names. And that's just the practical implementation of it. Now, coming to the question, what we're supposed to actually do about this question, let's get to it. They've given us a string, and that string consists of digits starting from 2 to 9, which is 2 all the way to 9, basically all the numbers that are mapped to alphabets in this picture. We have to return all the possible letter combinations that this string of digits could represent. What does that mean? We have an example over here. Let's say if the input was 2 3, right, we would get the output as given over here. But how do we get this output? Let's see that. To get the output, we will be looking at the algorithm that we popularly call backtracking. Now, to understand backtracking, let me bring over the key mappings that we have in the question, and help you understand that with the examples given to us over here. We have the key mappings, and the input given to us is the string of digits, that is 23. So how do we get this answer with these digits? Now, what we do with this backtracking algorithm is that first we process this layer that is provided to us by the first input, then we move on to the next set of input, and we do this one by one. For example, we have the number 2. 2 is mapped to A, B, and C, right? So we can start off our answer by going down 3 paths. The first path is choosing the character A, the next is choosing the character B, and lastly, we can choose the character C. Now, we can go down one path at a time, not together. So let's say we choose to go down the path that has character A in it. We build up our answer in such a way that our first letter of the answer for that particular combination will be A. What is the next step? We take up the next part of the input, that is the character 3, that its mapping is D, E, and F. So our paths will be laid out as follows. We can either choose the character D after A, or E, or F, and we do the same for B and C. So how do we actually build up our answer? I say that our answer can be stored in the form of an array, and the way we do it is we start by going down one path. So let's say I go down this path with the character A. This is where I am right now. So my first answer will start off with the character A. Then I have to choose one of the other paths. So let's say I go down to this path over here. I will add this to my answer. Now, are there any more paths for me to explore? Are there any more characters left in my input? The answer is no. So I will simply go back to A to check if there are more paths to explore from this point. Are there any more paths left? Yes. This is my next part of the answer. We have A and E, no further paths. We go back. Are there any more over here? Yes. We have A and F as part of our answer. Are there any more paths left for us to explore at this point? The answer is no. So we go back and go down the next path. We repeat this process, and by repeating, we get B and D, followed by BE, then BF. Then we'll go all the way back up, go down this path, do the same. We get CD, CE, and I'm sure you can guess at this point that we get CF as our last part of the answer. And once we are done exploring all such combinations, we simply return what we have over here. So let's see if that is what we get as our answer actually. And the answer is pretty much identical. And that is basically how we follow the backtracking approach. And some of you may have even guessed this at this point, we are actually brute forcing it. This is brute forcing it because we are trying out every single combination, because we have to return every single combination that can be formed with this input, right? So what are the maximum possible combinations that we can get with this sort of a mapping? The answer is 4 raised to the power n, where n is the length of this input string. Why 4? Because the maximum number of characters that we have mapped to any sort of digit is 4 in the case of 7 and 9. All the others have 3. So let's say if we get an input such as 9999 or 77 or something like that, it will be 4 into the power of the length of our input, right? That is what we have over here. And of course, this will be a recursive approach. And in the next video, we'll be implementing this. So stay tuned and follow for more.